Next thing. This problem is asking us for joules. It's asking us for energy. It's giving us wavelength. It's telling us it's 22.5 nanometers. You have to use both equations, okay? The reason being, you're given wavelength, you want energy. Your first equation is this. Okay, your second equation is that. Obviously, one will not work. You can't start with wavelength and magically figure out energy. You got to use both equations to solve. The step in between is going from wavelength to frequency, then frequency to energy. Again, this is a constant, this is a constant. Remember those. All right? But again, I will give them to you on tests. Like I said, in chemistry, you're given everything you need. It's just assume that you can use it. That's what you have to know how to do. So, the very first thing, the speed of light, c, is equal to 3.0 times 10 to the 8th meters per second. This is an issue. We're going to be plugging this value in, but nanometers does not equal meters. Okay? And this is why we did all that dimensional analysis stuff, because from now on, in chemistry, when you're given a number, and you're going to be multiplying, we'll say, two distances together, or doing something with a couple of different things, they must have the same unit. You can't do a problem where you've got millimeters and kilometers. You have to convert one to be the same. So we can't do something with nanometers and meters. It won't work. It'll be wrong. So we've got to convert from nanometers to meters. It's a really, really simple dimensional analysis problem. All you do, 22.5 nanometers, draw our little thing. Now, this is an easy conversion to remember. It's that 1 meter is equal to 10 to the 9th nanometers. 10 to the 9th. Nanometers are really, really small.
So we have to memorize it?
I will probably expect you to know this specific conversion by the time we take the test. All right? So, if you set it up, units on bottom cancel out. You don't even need a calculator. It's just, you know, you divide by an exponent, which means you're subtracting. So it's going to be 22.5 times 10 to the negative 9th, which we can then, if you want to write it in simplest form, 2.25 times 10 to the negative 8th. All right?
It's negative.
Wait, what?
Negative.
It's not negative 9 up there.
But you're dividing. When you divide by exponents, remember, you subtract. So 0 minus 9, because there's no exponent here, right? So 0 minus 9 is negative 9.
So what's negative 8 from?
This, all I did here, I moved the decimal over one spot, which means we add 1.
I didn't see that.
That's where this part came from. All I did was move the decimal
I didn't see
one spot, okay? So, are you with me to this point?
that. Sort of.
Okay. I know there's a lot. I'm trying to keep it.
Why can't we just like do the regular multiply?
What do you mean?
We can't.
Like, I did one. What I did. I did 3.0 times 10 to the 8th power equals 2.5.
Here's why. Sorry. Here's why. Because, like I was saying, this is meters per second. That's nanometers. It doesn't work.
Oh.
All right.
Okay.
So, step 1. Convert to frequency. You've got your formula. You've got your converted wavelength here. Now, what we're going to do, we're going to rearrange our formula to solve for frequency. So we'll even write it out. Solve for frequency. So you're going to say divide by wavelength, divide by wavelength. So C, that's a bad wavelength right there. And you're just going to plug stuff in. So 3.0 times 10 to the 8th meters per second over our wavelength, which again, we're using this now, 2.25 times 10 to the 8th meters.
Equal.
That'll equal frequency.
Which is
Are you with me to this point?
yellow.
I know, I'm going fast, I know. Now, as a review, here's what happened. We had C, speed of light, that was our constant. We plugged it in. Our wavelength was right here. We plugged it in. Again, this is no different than x divided by y. It's just they're symbols you're not used to seeing. Don't let them freak you out. Now, to solve for this, make sure that you put parentheses around stuff as you divide. And you should end up with 1.33 times 10 to the 16th. Now, here's the thing. Your meters are both on top. Those cancel out. You're left with seconds on the bottom. What should be on top then? 1, because a meter divided by a meter is equal to itself. Just cancels out. 1. So 1 over seconds.
Oh God, I lost you.
At what point?
I don't know.
All right.
I'll come to you later.
Now, let's take a couple tries. Yes? Oh, that's for when we're going to do this lab in a little bit.
Right
Now, I just had to make sure that the light was gone so we could actually see the lights we're going to put up on the back. Now, what we're going to do next, this was step 1. We have to do step 2 now. We're solving for energy. Now, the hard part's done. You've converted from nanometers to meters. You've plugged that in. You've done the math to solve for frequency. Now that you have frequency and you know what H is, again, it's a constant. You will always be told 6.624 times 10 to the negative 34th joules times seconds. You'll always be told that. All right? So all you've got to do, negative 34. This one's even easier. There's no division. It's just plug in frequency and Planck's constant. H is equal to this right here, what I'm writing. So we just plugged in H. We're plugging in frequency next. That'll give us energy. And if you look, seconds is on the bottom here, because remember, hertz is equal to 1 over seconds. That's frequency. Planck's constant, joules times seconds. All right? And then, so that means seconds will cancel out, because seconds over seconds just cancels out, so it's just joules times 1, which is joules, which is what we want. So you multiply these, and you should end up with energy being equal to 8.81 times 10.
Wait, how do the seconds cancel out?
No, here, let me show you. It's like, this is the same thing as saying joules times seconds times 1 over seconds. So do you see then how you would rewrite this as joules times seconds over seconds?
That's an S
All right. Now, yes.
How come it's joules times seconds rather than joules over seconds?
I think I told it to you wrong yesterday. I think I told it to you wrong yesterday. It's joules times seconds.
It's joules times seconds.
Any other questions?
No.
All right.